Too long, didn't watch. Black and white images limit your print resolution to the resolution of a pixel. Grayscale images allow you to get sub-pixel resolution. Steve here from Autodesk. On the Ember team, we're exploring how to use software to get higher quality prints without changing our hardware. Let's see how we can achieve some features that are smaller than the nominal resolution of the Ember printer. Theoretically, it all starts with the voxel. The voxel is the building block of DLP 3D printing. The size of the voxel, and in turn, the resolution of the printer, is defined by the pixel size of the projected image and the layer thickness in the vertical direction. So a print of a 3D model is an approximation of many tiny cubic voxels. In a single layer, the location of voxels is set by the projected image. If a pixel is white, the projected light will cure the resin and solidify a voxel. If a pixel is black, there is no light and the resin stays liquid. This means that if the voxels are 50 microns on a side, we can arrange them on a grid with 50 micron spacing. We could create a group of 4 voxels over here, and also another group of voxels spaced 50 microns away, or 100 microns or 200 microns, or some other multiple of 50 microns. But we cannot arrange them, say, 125 microns apart, because voxels are the indivisible atoms of DLP 3D printing, in theory. So far, we've been assuming that our image is composed of either purely black or purely white pixels. But what happens with a gray pixel? Would it print half a voxel? If so, which half? Top half, bottom half, left half, right half, center half? Richard Green on the Ember team created an experiment where he printed a solid row of voxels followed by a row of pixels ranging in brightness from very dark gray up to a fully white pixel. He found that pixels darker than a certain shade don't print at all. Then, at a certain point, a hemispherical bump forms attached to the previous layer. A brighter pixel produces a taller bump, and as the pixel gets brighter, the voxel grows wider and slightly taller. This means the size of a voxel can be controlled by varying the luminosity of a single pixel. In practice, we found that a gray pixel will tend to merge with an adjacent voxel. So, with 2 white pixels on the left and a gray pixel in the middle, the half voxel will form towards the left. If the 2 white pixels are on the right, the same gray pixel will merge with them towards the right. In practice, this allows us to do some really cool tricks. Here's an image slice of printing a small cube with a 10 pixel by 10 pixel cross section and another cube of the same size that's offset by 1 pixel. By using just black and white images, that's the best we can do with arranging the relative locations. Now, if we use gray values in the image, we can locate the cube with more precision than the projector should theoretically allow. This also allows us to create very precise vertical slopes. Here in the XZ plane is a cross section through a stack of slice images. Note the voxels are rectangular because the pixels are 50 microns in the X and Y dimensions, but here we've chosen to have 25 micron steps in the Z direction. We've got a vertical pillar of solid white voxels which would form a 90-degree angle with the base. But by adding a 1 pixel wide gradient of 32 gray values along the side, what we get is a very precise slope where each layer moves in roughly 1.5 microns from the layer below it. So instead of being perpendicular, we've added a precise draft angle of 3.6 degrees, all within a single 50 micron wide pixel. Here's another great example. Printing a slope of 75 degrees with just black and white pixels results in a stair-step pattern, because for every 7 or 8 25 micron thick Z layers, there is one 50 micron step over in the X direction. However, if we use grayscale, we get a finer resolution and we get a much flatter slope. This also works with shallow horizontal slopes. By using a controlled gradient of 32 gray values, we can create a very shallow slope, all within a single printed layer that has an average Z step of less than 2 microns. The slope is less than 1 degree above horizontal. These grayscale tricks don't magically allow you to print sub-pixel features, but they do allow you to reduce the layer lines and some other artifacts you see on 3D prints. Check out some other related videos like this one about the difference between video and pattern mode in DLP projectors. There's also an Instructable in the description that goes into more depth about printing single voxels with grayscale. Thanks for watching and have a beautiful tomorrow.